The next session, this is a technical session, elevating tooling standards with scientific injection molding. This is starting in the next, I think, couple of seconds. As we begin this, we might not be able to take questions at all in the interest of time and wrapping up. We have Mr. Subash Ellath, 100 Technologies, who's joining us for this session. Ladies and gentlemen, would you please join me in welcoming him up for his session, elevating tooling standards with scientific injection molding. Okay, Mr. Ellath, thank you so much for joining us. How are you doing today?
Yeah, great.
Good. Okay, I was just wondering if the audience, post-lunch is here with us. We're going to ask them to do something, okay? Mr. Ellath, can you say a hi to everyone?
Hi.
Okay, great. So we have a hi coming in right from the back. So we know that the stage is all yours, the audience is yours as well. Over to you, sir.
Thank you. Yeah. So, thank you, TAGMA, for the privilege. Respected toolmakers, dignitaries, industrial fraternities. It is indeed a great honor for me to be part of this prestigious International Tooling Summit. It was a wonderful arrangement. Over the above, it's a precious network opportunity for me. The second time I'm being in this summit. And warm good afternoon to one and all. Before going ahead, I would express my sincere thanks to D.K. Sharma sir, I don't know, he is here, and Nishan Kashyap for supporting me and engaging me for making this session possible. So, once again, welcome you all to this session on elevating tooling standard with scientific injection molding. Okay, we have heard about technology, everything, lot of 2 days. Now I am going back to the basics. Okay. So I started 5 years since I am into business, and I started with a vision. I started training the industry with a vision to advance Indian plastic molding and tooling industry and make it a global tooling hub for critical components. I mean to by critical tolerance components. I have worked in multiple companies, including Schneider Electric, L&T Tool Room, Sabic, GM Modular. Over 20 years of experience in molding shops, in the rheology, in the tool rooms, raw materials, mold developments. So I will make this statement. Everybody has already made it. 80% of injection molds face challenge with predictability in timelines after the T0 trial is made to the qualification. Okay. It's not because we don't have accurate machining centers. We have pretty good amount of good, accurate machining centers are there. It's not because of we have good molding machines. Neither we don't have the market in India. Plenty of market is there. Day by day it's improving. It's not due to unavailability of good standard mold standard parts or mold steels. It's not because we don't have access to technology. Are you agreeing with me? No, you're not agreeing. Agreeing. So what is the basic challenge? Is as per me, okay, I worked throughout the value system of injection molding and mold related plastic industry. What is the challenges, what I felt the industry is going through? There are a lot of new application coming day by day. It's not all the old type of raw materials nowadays. There are a lot of copolymers, there are multiple type of raw materials, there are specialty raw materials are there. And specialty polymers with tight tolerance parts and extended product performance are the call of the day. And everyone is focusing cosmetics, looks. The molding process, the molding machine is tweaked quite frequently, adjusting the molding process to achieve this level of aesthetics, I mean to say. There is a huge skill gap. Mold making is totally become an experience kind of thing. It has become like an art. Mold making is a science. Okay. There is a science, there is a calculation, experience, of course it is there, calculation, theory, practice and intelligence. Everything put together only mold making, to that precision can happen. So I've seen that industry is lacking major point of polymer. How many polymer guys are here in this program? Yes. Polymer is missing in the tooling industry. If we understand the real property of the polymer, then we can make. Just machining to the tight tolerance never gives a right tolerance on the part. That I mean to say. And lack of concurrent engineering. Concurrent engineering, I mean to say, inter-department. The designer cannot understand the language of the molder. The molder cannot understand the language of tool maker. There is a gap. We have to bridge this gap. We have to connect this dot. Until and unless we are connecting this dot, it's impossible to reach up to that level. That I mean to say here. What is the real expectation of any manufacturing process? If I tell what is the real expectation, it's just consistency. What I am producing now, the first shot to the second shot should match, second to the 10 should match. Today what is produced should match to the next month also. So the consistency, repeatability and reproducibility is a real the expectation out of any molding process. I will talk about molding because I am a molding person. And consistency in terms of dimension, one thing, in terms of cosmetics, in terms of performance and overall quality, everything is included that. Okay, even a rejection come, it should be repeatable. Suddenly a rejection aayega, suddenly bhag jayega. No, it should get repeatable. Then only predictability, then only we can do the modification. That I mean to say, that is what the consistency is what. I taken this with Suhas Kulkarni's image, okay, courtesy to Suhas Kulkarni, FilmTech. First level of consistency, when we talk of consistency in plastic molding, there is a 3 levels of consistency. First level of consistency is a cavity to cavity consistency. It means if we have a mold of 8 cavities, suppose or 4 cavities, all the cavities should behave the same way. If one cavity is behaving the different way, other is different, we cannot do any modification in the process setting. In terms of dimension, cosmetics, filling, pressure, whatever it is there, air winding, all the cavities should the same way. That is the first level of consistency. And the second level of consistency is shot to shot. The first shot should match. Okay, if all the cavities are matching, well and good. But if the first shot and the evening, Subash jo chal raha hai, morning shot, and evening shot, somebody is, part is getting catch. Dimension is getting deviated. It was okay. 6 months back, it was okay. Suddenly, aapka raw material mein some problem has happened. The lot has changed. No. This is the consistency we are talking, is the shot to shot. Every shot should match. Okay, this is second level of consistency. And there is one more level of consistency, is known as run-to-run consistency. I loaded a mold today and I ran for 3 days, suppose, and I downed the mold. After 6 months or 1 year, again loading the mold. And people are telling you, pata nahi hai, what happened? Mold was running right. Now it is not running right. This quite frequently I used to hear this question. And when I was in Shabik, in raw material field, people know, finally they have tried everything, then they will put all the blame in the raw material. Something has changed in the raw material, some magic. Okay, so this is known as a run-to-run. If we are able to match these 3 consistency, we should try to meet this, then our life is in good. We don't have to come early and go late from the tool room. That's my honest thinking. Okay. One thing, if we machine the tool still very nicely, correctly with the tolerance, can we get this consistency? Okay. Tool is being machined right, mold is being made right. What about the natural variations? There are a lot of natural variation. Those are out of our control. One could be polymer MFI variation. The polymer which is coming to us for molding, it goes through a lot of value chain. It comes from the crude oil. No, the crude oil converted into derivatives, then the monomer, it go to compounding, and too much value chain is passed and come to us, and we cannot expect it dot to dot. Every raw material will have lot will have same MFI. MFI means the viscosity. Finally, the flowability, it varies. So there is a natural variation. Second, environmental factors. The morning the temperature we have, noon the temperature, and evening we have, all are different. Different climates. It affects the mold. Mold is in that atmosphere only. So obviously the rheology is going to change. Even though I will tell this, see, if you see a mango, ripened mango, what is the color of a ripened mango? So yellow, orange. But we measure whether all the mangoes are the same, LAB values, color? No, there will be a difference. So whatever we get from the nature has a variation inherently. But suppose the ice cream made of a mango, same mango, if we get different colored ice cream, we will see it's a duplicate, correct, no? So end product, there is no variation allowed, but whatever incoming called material, variation is there by nature. So we are also in the same condition. Raw material variations are the natural variations. Still how we can produce a part which have no variation as per the tolerance. This is the tricky area where we are stuck in. So the solution for this is the scientific injection molding, and it's also known as decoupled injection molding. Sir John Bosley has coined this terminology, and many people like Subash Kulkarni have done a lot of work in this, a lot of research and spread across over the world. Okay? And it is, I will tell you, it is the process which natural variation will not affect the part. Whatever variation is there, you are still rescued. The process that respects the polymer inheritance, polymer behavior, nobody can change. No machine can change, no molds can change. Okay, its behavior intact remains whatever it is. Understanding polymer behavior, processing it, or making the tool. Okay, the process in which the result are completely depend on the creator, not on the molder. Molder doesn't have any work. He has to just load and put the program and run. Here the thing is, the creator means the designer to the tool maker and the qualification. That's all. Okay. This is not qualifier. Rather, I will call it as, actually it should be the science of injection molding. Since the name is scientific, many people ask, what is that? No, something new inside. Nothing new. It's the basic science of polymer, basic science of injection molding. That's all the scientific injection molding is. Okay. Before going ahead, I will just know, most of you will be knowing just one property, Newtonian and non-Newtonian property. So when we talk about Newtonian, see water. The fluids or whatever, which viscosity, patlapan, viscosity, the thickness will not change as with respect to the temperature. Suppose you are flowing water through a pipe in 30 degree, 40 degree, 50 degree. The amount of water coming outside will remain the same. There will not be different temperature. But think about polymer we are processing. If you are processing 250 degree, you increase the temperature 300, what is happening to the polymer? Thickness is reduced. That's why you are able to fill the part, somehow fill the part, extra lengthier part, correct? No? So, water is a Newtonian thing, but what is our polymer what we are molding? Is a Newtonian, non-Newtonian? Anybody? Non-Newtonian, correct? That's why it's, but I'll ask you one thing. If you operate with a material, with every degree temperature change, there is a viscosity change happening. Can you get consistency? That's my question mark. Never you can accept a consistency if you are operating with a material which thickness keeps on changing with every degree temperature change. Means every degree shear change. Shear change, then how you can achieve consistency? So the beauty of our polymer is, at certain shear rates, the polymer become Newtonian because its viscosity never change. We have to find out that point and process further to get a consistency. That's what the first step of a scientific injection molding is. Okay, what are the advantages of scientific injection molding? These are some generic points, but very, very real points. It improves consistency. Every shot will match. Every run will match. There will not be a surprising thing. It's a data-driven process. There are 6 steps to that. It's not just experience. Aaj aisa kiya, tomorrow somehow I am called. No. There is a step-by-step process for qualifying a mold, and it has to happen to the T0 trial, qualification of the mold. And robust step, very robust step, and it reduces defects. There is no surprising thing will come. And increase efficiency, of course, better process control, no need of taking the molding machine every now and then, because natural variation already are taken care in the process itself by understanding that Newtonian behavior. And very good predictable timelines. You were telling, no, T0 ke baad, or the mold is getting delayed because taking, adjusting. Nothing is required here. Okay. Lower part cost, because here yield rate are there, predictability is there. Enhanced performance, efficient troubleshooting. Where, troubleshooting is not hit and throw. Always you know what is the real root cause. There is no hit and throw when we are going for a scientific injection molding. How to achieve the consistency? The scientific injection molding way, SIM way. SIM is carried out in 6 steps. First is viscosity study. Understanding the Newtonian zone of the raw material where viscosity will not change with respect to shear or temperature, and processing it. Keep the injection speed as per that. That's the first level. Second, the cavity balancing. All the cavities, we will measure the weight of the cavities, whether it is within 5%, or based on that we can take a call whether cavities are balanced or not. It can be due to feed system imbalance. It can be due to air vent imbalance. It can be due to cooling imbalance also. And even machining, that quite easily we can find it out. Rest of the things, little bit hidden things. And third is the pressure drop. how much pressure the part is taking to fill. It's not, no, filling is not the task. Filling anybody can, mark ke band karne ke liye anybody can do. But how to fill, at what pressure it has to fill. See, for a cold runner road, it is normally said up to the feed system 30 to 35 MPa pressure drop is okay. And totally filling the part should be 70 to 100 MPa. Then we will be in control. Okay. If you are taking too much pressure, see how about our efficiency also comes. So in plastic molds also, if you are taking too much pressure and filling the part, forget about consistency. Okay, one important point. Then pressure drops, then cosmetic window. That's when we try to keep the cosmetics, bring the cosmetic by putting holding. Injection mold, if we see, the metal is being injected inside the mold in two phases. One is known as injection, second is holding phase. Separating both and thinking differently is known as decoupling. Decoupling them. So scientific injection mold is also known as decoupling. And then we go for a gate freezing analysis. If you see the gate is the smallest area in the mold. It's a wall gate, it's a different story, but I tell a common mold. Okay, even in the wall gate also there are secondary gates also in many of the molds, which doesn't even act. So the thinnest area in the mold freezes immediately, easily. So if the gate is freezed, now you are pressurizing from backside, nothing will go inside. So we should understand some of the semi-crystalline metal absorbs, nylon, some PP, you should know, very, very important for getting dimension stability and warpage control also. Gate freezing time, and then the cooling time. Cooling is money, so we have to have a cooling time study. Optimized cooling time based on the SDT of the raw material, not based on the catching of the runner. No, it's based on the heat distortion temperature. Eject the part 10 to 15 degree, that's good enough. Adjust the mold, okay, for catching, removal, all these things that we have to do in the mold. Okay, but all the pre-preparation should be done before doing the sim. First is the metal preparation, raw metal preparation, very, very important. There are something not drying. Drying, everybody knows. There is something not a cumulative drying time. Those things has to be done. And even the capacity of the dryer, very, very important. Nowadays we are going for specialty metals. We cannot use some dryers and heat it. No. The time, maximum drying time also is very, very important because some of the volatiles will escape if you are doing over drying. Melt preparation, setting the temperature in the machine is not the thing. The real temperature, what is coming out of the machine is important for us. So we have to prepare and measure also. Mold temperature is very important factor for the molecules to align. And the short size setting, how to shed. So injection has to be done up to 98% of the part, then 2% holding, that's all. Okay. Always inject 98%, 95 to 98% of the part by injection. Okay, this is what it is. So this is the viscosity study. See, here in viscosity, we'll start injecting the part, different shot in starting from a slower speed. We'll start with 30 speed, 35, 40, like that. And in each speed, what is the time for filling? Actual injection time, machine will show, all the machine shows. And what is the pressure it is taking, that also it will show. We have to just put in this and it will plot a beautiful graph. I told this area is the non-Newtonian area. If you are injecting in this area, forget about consistency. This area is the Newtonian area, where any change in viscosity or any change in shear rate will not affect the viscosity. Okay. So if you are able to inject in that area, of course, to inject in the area, you should have very good tooling strength because you will get a air entrapment issue, burning marks, near the gate marks, all these things. That's why I tell scientific injection molding is a tool maker's business, not a molder's business. Okay. So this is what Newtonian area you have seen. You have to operate in that area, first of all. Second is the cavity balancing. In cavity balancing, we'll take out the cavities and measure the weight in a precise way. And if it is within 5%, it's okay. That's how we can go ahead. If there is a variation, we have to find out due to cooling difference, due to machine difference, due to air venting difference, or due to gating difference. This has to be air venting, everything has to be plugged within the second, step of scientific injection, not after qualifying the part. Okay, then pressure drop study. Here what we are doing, we are studying how much pressure, first pressure drop happens in the system in the nozzle, machine nozzle, correct? Wherever restriction, pressure drop happens. First nozzle, then the screw bush, then in the runner, there will be secondary runner, then that also, and it can be in the gate and in the part. So we need to really identify where is the pressure drop happening. If the pressure drop is happening in the runner, you are correcting the gate, you will not get anything benefit. So Here, this process is done to understand where the pressure. If a pressure drop is happening in the part, you are keeping on increasing the gate, part will not fill. Finally, end of the mother, after 6 months, you will come to know this part thickness is lesser. Either you go for an next MFI grade or you go to the customer and ask increase the thickness. But this study will show you where is the problem. Immediately you can plug it. And even mold flow shows it. If you are really noticing that, it shows it. Okay, then comes the cosmetic window, the holding. Till this time, we will not put any holding, we will be only doing injection. This is the cosmetic. Here, above the cosmetic window, it goes means it's a flash, lower means is a sink mark. We will identify a window wherein, and we will pick the center point and start the holding parameters. Next thing is known as gate freezing study. Here, what we will do, we will keep on increasing the holding time from 1 second to 2 seconds, 2 to 3. And we keep on measuring the weight of the part. Okay. Maybe automotive bigger parts may not be so much not possible some case, but in smaller critical part this is very much possible and it has to be done. So we will keep on increasing. After some time we will get the gate is freezed. Gate is freezed means nothing will go inside. So this time has to be done. In this time the metal is not crystalline metal, not become crystalline. Suppose you will not get consistency means warpage will come, your dimension keep on changing. You are telling no, suddenly dimension after some days is changing because crystallinity is not met. Okay. Then comes the cooling time. Cooling is money, 60% of cycle time is cooling. So based on the HDT, measure the part temperature and take a call how much cooling optimum time is required. Then if I talk about the qualification in same way, first step is deriving the molding process. Second, cosmetics, and final only the dimension. Never touch the dimension at the T0 time. Because you change the gate, your dimension is going to change, especially for crystalline materials. Higher the crystallinity, higher you are in trouble. You will not have the steel to correct later on. So dimension is the last. First the process, air vending, everything do it, then only go for that. Okay. So the knowledge one should have, plastic raw material behavior. Plastic raw material behavior is very, very important. We cannot avoid that and go with scientific injection molding or critical part. We cannot do it. Okay. Not just MFI on data sheet reading. No. Understand the rheology behavior. That is important. Material selection about the data sheet. Go into data sheet little more in deep detail. The shear rates. Mold design. Shear rates. I seen the total industries overlook the shear rate. Most of the people are not aware of the shear rates. So that's why I put the feed system sizing. Sizing and construction is very, very important. Cooling and vending. Feed system sizing is not just an experience. It's the first level of feed system sizing as per the shear rate of the raw material. Then it goes to the mold. We have to see the pressure drop study, gate freezing study, then experience. All put together is a feed system design. Not just experience, I mean to say. And product design one should know the thumb rules and predictive analysis, mold flow report interpretation. I am not telling mold flow report making, but interpretation. A lot of things are hidden inside the mold flow report that has to be properly interpreted. Material preparation, process establishment, I told you by decoupled method, root cause analyzing, and auxiliary machine and machine sizing and selection also very, very important. Okay. But to get immediate result, if you ask me one question, what the industry is overlooking, I will tell you, just you rub your hand. Can you rub your hand? Karo na? Kya hona? Okay. What is happening? Heat is generating, correct? So, if you think the raw material is a byproduct petrochemical industry, the molecules are getting rubbed each other when we are injecting a higher speed. Huge amount of heat and shear is happening. We cannot forget that. That will lot of aesthetic problems, lot of dimension problems. These really overlooked in the industry. Let us concentrate on that. I will tell you at least 30% improvement come from just shear rate calculation. If you require shear rate simple I can give to you. If you are having multiple wall gates in a mold, automotive parts, remember that I seen most of the mold flow report shear rate plots are deleted because there is no answer. No, because instead of 1 lakh it shows 25 lakhs. Nobody has an answer. Okay. But if you are able to maintain every gate within 5 to 10% shear rate, your aesthetics automatically comes. Every wall gate you are able to 5 to 10. It's a challenge. You can tell some of auto people, it's a challenging thing. Okay. You can get a very good aesthetic part because automotive people, most of the people are struggling with aesthetics and shining, all these things. Okay. Yes, done. So to end this, consistency can only be achieved when a creator knows the molding process and the root cause. Molding process means nothing, that graph बनाने के लिए आना चाहिए, molding machine set करने के लिए आने की जरूरत नहीं है. Okay, then mastering this approach paves for an excellent in mold and predictivity. Okay, that's all from my side. If anybody wish to connect with me and wish to know our service, you can just scan the QR code. I am available. Okay, even if you require some shear rate calculation also, I will share it. Thank you. Thank you.
Thank you so much. May I request you to please join us center stage. May I request Mr. Shijesh Kokadan, our EC member, to join us on stage to hand over token of felicitation. Ladies and gentlemen, the last two sessions that are now there, there's the next technical session that is starting in the next couple of seconds. We'd like to take this opportunity to thank Mr. Subash for joining us for this session. Thank you so much, sir. Ladies and gentlemen, let's put our hands together.